Hello, viewers. In today's session, we are going to discuss a very important and very conceptual problem from domain of functions, right? And here we are given a function y, which is equal to square root of 2 times cos inverse x minus sine inverse x, and we have to find the domain of this function y, right? So by domain of a function, we mean that all the valid values of x, right? So we have to find all the values of x which define this function y. So here we have a combination of two inverse trigonometric functions, and we'll see how we can find out the domain of this function y with the help of using the properties of inverse trigonometric functions, right? So let us start. So here we see that we have the expression 2 cos inverse x minus sine inverse x inside the square root sign, right? So whenever we have a number, say square root of a, then for the validity of this number, that is, if we want to express this square root of a in the set of real numbers, then this a must be greater than or equal to 0, right? So this is the condition for having this number, or having this expression square root of 2 cos inverse x minus sine inverse x to be in the set of real numbers, right? So the first condition is that this number, that is 2 cos inverse x minus sine inverse x, must be greater than or equal to 0, right? So now here we have this inequality, and now we'll proceed from this inequality to get the domain of this function. So let us solve this inequality step by step. So what we can do, let us substitute here cos inverse x as pi by 2 minus sine inverse x, right? So here we have sine inverse x, and here we have greater than or equal to 0. So here we have used an important property of inverse trigonometric functions, that is sine inverse x plus cos inverse x is equal to pi by 2 for all values of x belonging to the interval minus 1 to 1, right? So we have written cos inverse x is equal to pi by 2 minus sine inverse x. So here we have this expression for cos inverse x. So now multiplying these two numbers by 2, we have pi, then we have minus 2 sine inverse x. Here we have sine inverse x greater than or equal to 0. So we have pi minus 3 sine inverse x greater than or equal to 0. So let us take this number to the right hand side. So we have pi is greater than or equal to 3 times sine inverse x. So let us rearrange the terms here. So we can take this 3 in the denominator of pi. So we have pi over 3 greater than or equal to sine inverse x. And we can also write this inequality as sine inverse x is less than or equal to pi by 3, right? So this is an important step in this problem, right? So we can call this inequality as inequality number 1, right? Okay, now here let us use one more important result from inverse trigonometric functions, that is the range of sine inverse x is it belongs to the interval minus pi by 2 to pi by 2, right? So sine inverse x must lie between minus pi by 2 and pi by 2, including both these numbers. So we can also write it like this: sine inverse greater than or equal to minus pi by 2, and it is less than or equal to pi by 2. So we can call this inequality as inequality number 2. So now we have to merge these two inequalities, right? Now see here we have sine inverse x greater than or equal to minus pi by 2, right? So here if we insert this part in this inequality, then here we can write sine inverse x greater than or equal to minus pi by 2, right? So now this inequality can also be redefined as the sine inverse x greater than or equal to minus pi by 2 but less than or equal to pi by 3. So what we have done here, from this inequality, we have taken this part, that is sine inverse x is greater than or equal to minus pi by 2. So here we have inserted minus pi by 2 here, so that sine inverse x is greater than or equal to minus pi by 2, but it is less than or equal to pi by 3 due to this inequality, right? So now let us take the sign of all these three numbers, right? So we have sine minus pi by 2, and here we have sine of sine inverse x, and here we have sine of pi by 3, right? So what we have done, we have taken the sine function of all these three numbers, right? So here we have minus sine pi by 2, because sine minus theta is equal to minus sine theta, and here this sine and this sine get cancelled, because we know an important property of inverse trigonometric functions, that is sine of sine inverse x is equal to x for all x belonging to the interval minus 1 to 1, right? So here we are left with only x, and here we have sine pi by 3. So viewers, here we have also an important thing to note, that when we have taken the sign of all these three numbers, then the direction of the inequality, it doesn't change, right? So it remains the same, because the function sine function is an increasing function in the interval minus pi by 2 to pi by 2, right? So sine function is increasing in this interval. So we can also see this fact from the graph of sine function, right? See here we have the graph of sine function, and this is the sine function, and here we have minus pi by 2, and here we have pi by 2, right? So from this point, that is from point A to point B, when we go from minus pi by 2 to pi by 2, then we get this curve, right? And from A to B, the sine function is increasing function. So now the value of sine pi by 2, that is sine 90 degrees, is 1. So we have minus 1. Here we have x, and here we have sine 60 degrees, which is square root of 3 over 2, right? So we have got our domain, that is the domain of this function. So x, it belongs to the closed interval, that is from minus 1 to square root of 3 over 2. So this is the required domain of the function y is equal to square root of 2 cos inverse x minus sine inverse x, right? So this is how by making use of all these concepts, we can easily arrive at the domain of functions.